If you have attended the workshop yesterday, guys, in the morning at 10 o'clock.
Okay, so first is
Okay, this is your first session. Okay, no worries, guys. Today we'll be taking up a small, I think, a demo class on one of the prerequisites for cybersecurity, which is, again, basic networking fundamentals. Let me share my screen. I hope the screen is visible now, guys. Everyone?
Yes.
Chandrakant,
Yes.
Himansh.
yes.
Perfect, perfect, perfect. And is there any background disturbance, guys? Because again, I'm still traveling back to my home. I got a bit late at the office today. So I hope there's no background disturbance. I hope I'm clearly audible and there's no other sounds or disturbances. Any issues as such?
No,
Everything
you are
good,
clearly
sir.
audible.
Perfect, perfect. Right, let's just wait for 1 or 2 minutes more, guys, and we'll start the session. In the meanwhile, if you have any questions also, you can let me know while we wait for the others to join. Okay, guys. So yeah, let's get started without any further ado. I guess everyone is here. So as mentioned earlier, guys, this is the class on basic networking. This is one of the prerequisites in cybersecurity, understanding what networks are, what are IP addresses and all. So this whole week it's going to be demo sessions for people to understand how the classes are going on and if this course is suitable for you or not. So yeah, let's get started. And yeah, first when you talk about networking fundamentals, there are three important definitions to know. What is networking? What are networks? And what are hosts? So when you talk about networking, this is the practice of connecting information devices. Now, what I mean by information devices is which again devices which are capable of transmitting data to each other, sending and receiving data from other devices. Example, your mobile phones, your routers, your laptops, your wireless headphones or wired headphones or whatever it be. Okay, devices which are capable of transmitting data to one another are known as information devices or hosts. Okay. And networking is the concept of connecting these devices with each other to share that information. So when you talk about a network, it's a group of these devices. A collection of these interconnected systems is called as a network. And each of the devices in that network is called as a host. Okay. So again, when you hear the term host, again, it is equivalent to any device, any information device, which is capable of sending and receiving data from other devices. Now, just like how we humans can communicate with one another, we can talk to each other and address each other with our respective names. These devices also have their names, and that name is called as an IP address, which stands for Internet Protocol Address. So this IP address was built by the US military in the late 1950s or 1960s. Okay, and there were various versions of IPv4 and IP addresses. There was IPv1, Internet Protocol version 1, Internet Protocol version 2, Internet Protocol version 3. These were quite experimental, didn't work out successfully. What properly worked out was IPv4, Internet Protocol version 4. And we're still using that IPv4 version even in today's world. Okay. Now, to define what an IP address is, as mentioned, each device or each host on a network has a unique name to it, a unique identifier to it. And that is called as an IP address, excuse me. Okay. And this IP address allows for communication to occur between all the devices because now they have an address, they have a name to communicate with each other. Okay. Now this IPv4 has a few properties to it. Let's go ahead with that. First things first, this IPv4 address is a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros or ones consecutively. Each bit has a value of 0 or 1. And this is the fundamental data on which computers or information devices transmit information to each other in the values of zeros and ones. Okay. So this is also commonly known as binary language. language of only 2 digits, either 0 or 1. And your IPv4 address contains 32 bits as such, 32 zeros or ones. And this whole 32-bit address again is divided in 4 equal parts of 8 bits each. And that each 8-bit portion is called as an octet. So your whole IPv4 address is a combination of 4 octets here. And each octet is divided by a dot symbol. So this is what your typical IPv4 address looks like. Combinations of zeros and ones, in total 32 bits. And that whole 32-bit address is again divided in 4 equal portions called as octets. Now this is what a computer reads, but we humans cannot understand binary so easily. So what we regularly use or understand are decimal numbers, numbers ranging from 0 to 9. So this binary address can actually be converted into a decimal number as such. Okay. So now we're going to learn how do you convert any binary number to a human readable decimal number. So here this number 11000000 is actually equivalent to 192. This number 10101000 is actually equivalent to 168. Okay. All zeros is equal to 0 and 00001010 is actually equal to 10. So now we're going to learn how are these numbers getting converted, what is the logic behind them and what is the mechanism. Okay. So again, why do we need this conversion? Just so that we understand the range of IP addresses. What's the first IP and what's the last IP can be calculated by converting any number to any binary number to a decimal number. Okay. So let's get started with that. So let's take a random binary number here. Let's say 10101010. Now, if we had to convert this number to a decimal number, there are two simple rules. Rule number one is you assign values of 2 power to each bit from right to left. So if I have this number 10101010, below that, I'm going to write down these values ranging from 2 power 0 all the way up to 2 power 7. If you specifically ask why only 2 power, this is a binary number. You only have two possibilities. So the rightmost bit is 2 power 0, leftmost bit is 2 power 7. Okay. And once you have written down all those values, you multiply the lower bit with the top one and keep on adding it with the next one. So to calculate the final decimal number, you would get 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So when you calculate that whole number, you get the final decimal answer. Okay. So if we calculate this out, let me write down the values for the 2 power numbers first. Anything to the power 0 is always equal to 1. It's just a mathematical rule. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. So if we start calculating now, 2 power 0 into 0, that's simply 0. 2 power 1 into 1, that's 2. 2 power 2 into 0, 0 again. 2 power 3 into 1, 2 power 3 is 8. So into 1, that's 8 again. Okay. Then 2 power 4 into 0, 0 again. 2 power 5 into 1, oh, wait, over here, sorry. 2 power 5 into 1, 30. 2 power 6 into 0, 0 again. And 2 power 7 into 1, that's 128. So if you add all this up, you get the number 170. 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. Something like high frequency and low frequency data. High, low, high, low, high, low, high, low. Okay. So this is how you can convert any decimal number, any binary number to a human readable decimal number. Is that clear, guys? Chandrakant, Himanshu, Kripa, Narsimha. Who else is there? Yeah, that's all.
Yes, sir.
Yes.
Any questions or doubts up to this point? Narsimha, Himanshu, Chandrakant, Kripa.
No, I have no questions, sir.
Perfect.
Yes, sir.
So if you have understood this concept, guys, I have two other numbers here. Let me go to the next presentation slide. So there's two numbers here, 01010101, and then second number all ones in binary. So if you have a pen and a paper beside you, can you calculate and give me the decimal numbers for it, the decimal equivalents? Okay. So I've written down the two numbers here, 01010101 and all ones. So again, take your pen and a paper if you have one beside you and try to calculate and give me the final decimal answers. Again, guys, please do let me know if you have not understood this concept. I can explain again. Again, do not hesitate to ask me your questions. Okay, I'm here to make you understand these concepts in the easiest format. So if you don't understand it, no worries at all. So if you're completely new to networking, this might seem a bit tough. So do not hesitate to let me know. Okay, I can clarify them one more time if you want me to. Okay. So assuming there are no questions for anyone, please do let me know if you get the answers. 0 1 0 1 0 1 0 1 and all ones. And please no cheating, guys. And do not search for this equivalent in your browser and give me the answer. Please take a pen and a paper if you have this idea and calculate and give me the correct answer. Take your time.
Anji.
Yeah, Chandrakant. Any answers for the first one or the second one?
86
You
people.
can. Your voice is a bit unclear, Chandrakant. I can't hear you properly. There's some static coming in your voice.
For first one it is
250.
86 and for second one it is 252.
Oh, okay, we'll check it out, guys. Narasimha also has given his answer in the chat box. Okay, let's check the answers in a minute, guys. Let's wait for the others to answer as well. Okay, guys, I've got some answers from almost all the students. Let's check the answers now. So the first number, 0 1 0 1 0 1 0. So I have the values for 2 power 0 to 2 power 7 on the right here, if you have noticed. So first number, if you have 2 power 0 into 1, that's 1. 2 power 0 is 1, so 1 into 1, that's 1. 2 power 1 into 0, that's 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0 again. 2 power 4 into 1, 16. 2 2 power 5 into 0, 0 again, 2 power 6 into 1, 64, and 2 power 7 into 0, 0 again. So 64 plus 16 plus 4 plus 1, that gives you the answer as 85 for the first number. Second number, you have all ones here. So all you have to do is add all the numbers. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And you would get the final number as 255 here. Okay. Sorry, those are the answers, guys. I've got some correct answers and a few wrong ones. Okay. But I hope you understand, guys, where you're going wrong. Okay. Just in case if you got the wrong one. Okay. Any questions or doubts, guys, for anyone who has, again, not gotten the correct answer? I hope you have understood where you went wrong, guys, so that you can make the correction next time. Okay. So in a real-time scenario, you will never be asked, guys, to convert any number from binary to decimal as such. But this is for your understanding to know what the range of IP addresses are. So if I had to calculate the first IP now, all I have to do is put simply all zeros everywhere. So in the first octet all zeros, second octet all zeros, third octet all zeros, fourth octet all zeros. When you convert that to decimal numbers, you simply get 0.0.0.0. That's the first IP address. And if you have to get the last one, you put all ones everywhere, the maximum number. And for that, you would simply get the last IP as 255.255.255.255. Here's the first IP, and here's the last IP. So now you logically know why all the IPs are ending at 255, 255, 255, 255. So you can never see an IP address above the number 255, guys. That's the maximum upper limit. Okay. So any octet can go or range from number 0 to 255. You will never have an IP in the negatives or in the number above 255. It's an important point to note. And the logic behind this is the binary to decimal conversions. Okay. Now, if you were to ask me how many IP addresses do we have in total, if you notice over here, we have 32 bits. And in each bit, we have two possibilities, either 0 or 1. So if someone had to calculate the total number of IP addresses, you just simply get it by 2 to the power 32. So you have two possibilities in each bit. And since there are 32 bits, you would multiply 2 into 2 into 2 into 2 into 2 into 2. Like that, 2 to the power 32, you would get 4.3 billion IP addresses in total. Now, my question to you is, in today's world, will 4.3 billion IPs be sufficient? So again, as mentioned from the first number till the last number, we only have 4.3 billion IPs. So are these IPs sufficient in today's world? 4.3 billion, definitely a huge number, but will that be sufficient by any chance? Chandrakant, Himanshu, Kripa, Narsimha. Any answers, guys? Again, guys, let's keep this session a bit interactive and fun, just so that I don't bore you out with the concepts. 4.3 billion IPs sufficient in today's world by any chance? The population itself is 8 billion people. And again, each person can own multiple devices again. Okay, if I talk about my scenario here, I have a laptop, I have a phone. Okay, so I have minimum on an average 2 devices. So definitely 4.3 billion IPs might not be sufficient, right? So that is why when they understood that in the future, when these 4.3 billion IPs might not be sufficient for a world with such a high population, they came up with a concept called matting, or dividing these IPs into various categories. So there's something called as, before we get into the sequence part, there's something called as classes. So there's class A, class B, class C, class D, and class E. There are 5 categories. And again, in each of those categories, there are 2 subcategories as well. There's something called as public IPs, and then there's something called as private IPs. So we'll talk about all these categories in the next session, guys. We'll talk about what classes are, what public and private IPs are in the upcoming sessions. But now let me talk about the sequence of IPs. Okay, so as mentioned, please remember there are 5 separate categories called classes: A, B, C, D, and E. And again, in each of those categories, there are 2 subcategories: public and private, public and private, public and private. Class D and Class A are exceptions. There are no private IPs in them. They only have public IPs. Okay. But don't worry, what are these public and private IPs? We'll cover that in a bit. Okay. But coming back to one slide earlier, there's a certain sequence of IPs. Okay. So we know what the first IP is. We know what the last IP is. But what about the sequence in between? So to understand the sequence as well, there are 2 simple rules. Rule number 1, you always increment from the rightmost octet. What I mean by that is, if I show you this with a notepad file, just a second. So let's assume we have the first IP here as 0.0.0.0. Let's assume this is the first IP. Now, according to rule number 1, you always start with incrementing with the rightmost octet. So if this is the first IP here, next IP would be 0.0.0.1. Okay, you're incrementing or increasing the rightmost bit with 1. Next number 0002. Next number 0003. Next number 0004. Next number 0005. This goes on all the way up to the number 000253, 000254, then 000255. Now remember guys, 255 is the maximum number. You cannot have an IP like 000256 after this. Okay, so once it reaches the maximum octet there, after that you move to the left octet. So this 0 now increments by 1. So that's rule number 2. After the rightmost octet is completely filled, then the left octet increments by 1. And the rightmost octet, 255, cycles back to 0 again. Now after 010, don't directly jump to 20. This is wrong again. Okay. Remember rule number 1, always increment the rightmost octet. So after 0010, you have 0011. Okay. So the rightmost octet increases by 1. After 11, you have 0012, then 0013, then 0014. Goes all the way up to 001255. After this, you have 0020, then 0021, 0022, 0023. Goes up to 002255. If you notice, there's a pattern repeating here: 00 to 0255, 10 to 1255, 20 to 2255, 30 0030 to 003255, then 0040 to 004255. Like that, this keeps on going till the end octet, 002550 to 00255. What happens after this? Same logic. Once the rightmost octets are completely filled, the left octet will increment by 1. So next is 0100. Okay. Now same logic again, guys. So whatever repeated here from 000 to 0255255, same cycle repeats again from 0100 to 01255. Okay. Same repeats again. After 00, you would have 0101, 0102, 0103. Goes up to 010255. Then 0110, 0111, 0112. Goes up to 011255. Okay, like that, the cycle keeps on repeating, and somewhere down the line you would have 012550, 012551, 255, 22553. Goes up to 255255. Same after that, 0200 to 02 255 255, 0300 to 03 255 255, 0400 to 04 255 255. Like that, the cycle keeps on repeating until you have 255000. Oh, sorry, 025500 to 0255 255 255. Now, once all these 3 octets are filled, what happens after that? The 0 changes to 1. So you have 1000. That cycle goes on all the way up to 1, 255, 255, 255. Then 2000 to 2255, 255, 255. 3000 all the way up to 3255, 255, 255. Goes on all the way from 255000 up to 255, 255, 255, 255. Here's the first IP, and here's the last IP address. And as mentioned, if you keep on counting all those IP addresses one by one, you would have a total of 4.3 billion IPs from the first one till the last one. And that's the same sequence which I've shown here. Okay, so this whole range of IPs is 4.3 billion. And again, as mentioned, these 4.3 billion IPs are divided into 2 categories again: public and private, and certain classes. So we'll talk about what these categories are, what are public IPs, what are private IPs, and what are classes in the upcoming sessions. Okay. This is just a brief introduction to what IP addresses are in today's class. Okay. Is this clear? Chandrakant, Himanshu, Kripa, Narsimha, any questions or any doubts up to this point?
No problem.
No, sir, everything is pretty clear.
Perfect, perfect, Kripa. So yeah, that's it, guys. This is for the first demo session here today. We'll be connecting back tomorrow at the same time, and we'll be progressing a bit more further on IP addresses. So we'll be learning what are these categories. We'll learn about public IPs. We'll talk about again public and private IPs. We'll talk about the difference in each of these classes, the range of these classes. Okay, we'll also talk about a few important protocols, such as what is a DNS protocol, what is a DHCP protocol, what is subnet mask, how do you assign a private IP to your system manually and automatically with a DHCP server. So all these advanced concepts will be covered in upcoming sessions as well. Okay. So again, as mentioned, guys, these are demo sessions. I'm going to take them slightly shorter because I need all the students to be there. So this whole week will be having demos itself. We'll gather all the students, and once a batch is formed, you'll have much longer sessions from next week. Okay. So as mentioned, guys, these classes are for free. You can join the first week for complete free without making any payment. So please do join the sessions tomorrow and the whole week as well to learn all these concepts and then decide if this course is suitable for you or not. Okay. So yeah, that's that, guys. Again, I'll be sharing this notepad file as well once I get a confirmation on who all have registered. So until then, I might not be able to share any material, but once I get a confirmation on the payment, I'll be sharing all these presentations as well with you, and you'll be getting the recordings as well for each and every session. Okay. So that's that, guys. Nothing further. We'll exit the session here, and we'll connect back tomorrow at the same time. Okay. Bye bye. Bye Kripa. Bye Narsima. Bye Himanshu.
Sir, I have
Bye.
a question.
Yeah, Kripa. Go ahead.
Yes, I'm not sure if you spoke with my trainer, but my schedule is working just a bit different for these classes. So I
Uh-huh.
don't meet with you every morning.
Yeah, I was informed on that, Kripa. So you'll be joining two different batches. This one of this, I mean, some days on this batch and the other one on your evenings, I suppose, or your mornings. I've been
Yes, my
informed about that.
evenings.
Yes, I've been informed. I was informed about that from the counselor. No worries about that, Kripa. You'll be
Okay,
getting the
great.
recordings in the exact sync order. So you won't be missing out any of the recordings or the notes, and you'll be in track. I have been
Okay.
informed about that.
Yes, sir. I've been studying network security in my college a little bit. I took one or two classes, so I do already have a pretty good understanding of it. And
Perfect.
calculating the binary numbers and all of the things we did today. It was definitely nice to have a little review anyways.
Thank you, Kripa. Sure. Again, as mentioned, I'll be sharing the recording of the earlier class as well, just to give you an introduction on what topics we'll be covering throughout the course. So again, that might give you an overview about the whole course as well.
Okay, great.
Sure. So
Sure,
yeah,
thank you
that's that,
so much
guys.
for your help, sir.
No problem. Anytime. So
You
that's
have a
that,
great
guys.
day.
Nothing further.
Take care.
Thank, thank you, Kripa. Likewise. So that's it. We'll connect back tomorrow at the same time and discuss the remaining concepts as well, guys. Please do join the session tomorrow without fail. Bye bye. Good day.